Students, so in this video we will be solving the MCQs of chapter number 9, that is ray optics. Clear? Okay, so the first one, this is a question of your textbook. Earth takes 24 hours to rotate once about its axis. How much time does the sun take to shift by 1 degree? This is very easy when viewed from Earth. Okay, so Earth is taking 24 hours to rotate once about its axis. So, in a time interval of 24 hours, Earth completes one rotation, that is the shift will be of 360 degree, right? Shift of 360 degree will take 24 hours. So, how much time does the sun take to shift by 1 degree? So, for 1 degree, what will be the time? For 360 degree, the time is 24 hours. So, for 1 degree, the time will be 24 by 360. So, this will be this many hours. So, your options are in minutes. So, it will be 24 by 360 into 60. Because 1 hour is 60 minutes. So, I have converted this into minutes. So, it will take 4 minutes to have a shift of 1 degree. Clear? So, B is your correct option. Fine? The next one. Okay, the second one. A magician during a show makes a glass lens with refractive index 1.47 disappear in a trough of a liquid. So, what is the refractive index of the liquid? Again, this will be your example in the textbook, and this was the MCQ asked in board exam. Magician during a show makes a glass lens with refractive index 1.47 disappear. He is making a glass lens to disappear in a trough of the liquid. So, we need to calculate the refractive index of this liquid. Well, we know this formula, 1 by F is equals to N2 minus N1 by N1 into 1 by R1 minus 1 by R2, right? Where F represents the focal length of the lens, R1 and R2 are the radius of curvature. Okay, now, one refractive index is already given, that is the refractive index of lens is equals to 1.47, right? He is making the lens to disappear. It means when the refractive index of glass lens equals to that of liquid, right? When the refractive index of lens is equals to refractive index of the liquid, then focal length will be infinite. Focal length will be infinite, it means rays after refraction becomes parallel and they will never meet, right? So, we will never observe the image formed by the lens. Once again, suppose if I am substituting here 1.47 minus 1.47, that means I am taking the refractive index of the liquid as 1.47, that is same as that of lens, right? So, 1 by F will be equals to 0, so F will be equals to infinite, right? Focal length means the distance where the rays after the refraction meet. So, focal length is infinite, it means rays after refraction will be parallel to principal axis, that means it will form the image at infinite, or rather you can say that will not be able to see the image at all, right? So, magician is making a glass lens to disappear. This happens only when the refractive index of lens will be equals to refractive index of the liquid. So, after the refraction, rays won't meet at a particular point. So, we will not be able to see the image of any object. So, we will find that the lens has been disappeared. Clear? If suppose the lens is say convex lens, right? Convex lens, and if we are placing it in a greater refractive index, this is just for your knowledge, that means we are having a convex lens whose refractive index is say 1.47, and we are placing it in a medium with refractive index greater than 1.47, let us say 1.48, then the focal length will be 1 by f equals to 1.47 minus 1.48. right? So focal length will be negative. It means convex lens will look like, that means convex lens will behave like concave lens. Whenever you are placing a convex lens whose refractive index is 1.47 in a greater refractive index, the refractive index of lens is say n1, and you are placing the lens into another medium whose refractive index is greater than that of lens, then convex lens will behave as concave lens. Clear? Then presently the question was, the magician is making the lens to disappear. This happens when the refractive index of lens will be equals to that of a medium. So your answer will be option A, 1.47. Is it clear? Fine. The next one. Third one, for Rayleigh scattering, which condition should be followed? The condition is already given in your textbook. Lambda is the wavelength of light incident and A is the size of the scatterer. Okay. According to Rayleigh scattering, the size of the particle that scatters the light should be very less than the wavelength of incident light, right? This is what the Rayleigh scattering is. If the size of the particle which emits the light is smaller than the wavelength of incident light, that means size of the particle, that means the diameter. So A is the size of the particle. This is quite smaller than the wavelength of incident light, right? That means when A is less than lambda, only then the type of scattering is known as Rayleigh scattering. So this is a correct condition for Rayleigh scattering. Clear? C is your correct answer. Fine. The next one. Fourth one. The far point of a myopic person is 80 centimeter in front of the eye. Myopic person means person having nearsightedness. That means image is formed before the retina or in front of retina, not on the retina. So basically he wants the rays to get diverged. So for diverging he needs to use concave lens, right? So image is formed at 80 centimeter. So that is 0.8 meter, right? And since what is the power of the lens, this is being asked. So he will use a concave lens because concave lens is a diverging lens. The lens will make the rays to diverge, so that image will be formed on the retina and not in front of the retina, right? So for a concave lens, focal length is negative, so power will be 1 by f, so that will be minus 1 by 0.8. Clear? 10 by 8, so it will be minus 1.25 diopter. So he will have to use a concave lens of minus 1.25 diopter power. So that means D is the correct option. Clear? Myopic person means person having nearsightedness. That means he will be able to see the objects, nearby objects, and he will not be able to see the far away objects. Clear? Fine. The next one. Fifth one. An object is placed at 10 centimeter in front of a concave mirror of radius of curvature 15. Find the image distance. Find where the image will be formed. Okay. So concave mirror, radius of curvature is given as 15. Fine. So focal length will be r by 2. So it will be 15 by 2. Object distance is given 10 centimeter. We need to find the image distance. That means V. We know this formula, 1 by f is equals to 1 by v plus 1 by u, right? Okay. See, one thing is important, do not apply the sign convention for the quantity which we need to find out. Clear? That means, see, we have been told to calculate the image distance. So I will not put any sign convention here, because that is what we need to find out. Then before finding image distance, I cannot put plus or minus. Keep it as it is. Find the focal length of a concave mirror will be negative. So it will be minus 2 by 15 V. That is what we have to find out. So I will not place any sign. Object distance is again negative. So minus 2 by 15 plus 1 by 10 equals to 1 by V. So you'll get the answer along with the sign. So this will be the LCM 30. Minus 4 plus 3 equals to 1 upon V. minus 1 by 30 equals to 1 upon V. So V is equals to minus 30. That means image will be formed in front of the mirror at a distance of 30 centimeter. So this is your correct option. Clear? Fine? Okay, the next one. Sixth one. Brilliance of diamond is mainly due to the glittering of diamond is because of course, total internal reflection. It is because of this total internal reflection, diamond is glittering. Clear? Fine. The next one. Light from a point source in air falls on a spherical glass surface. A single spherical surface of refractive index 1.5 and radius of curvature 20. The distance of light source from a glass surface is 100. That means say this is a single refracting surface. Light source is placed over here. So object distance is given as 100. Right? Refractive index, this is given as 1.5. Radius of curvature is 20. This is air. So refractive index will be 1. What position the image is formed? That means we have to find V, image distance. So for a single spherically refracting surface, we'll have the formula minus n1 by u plus n2 by v equals to n2 minus n1 by r. Clear? Fine? So minus n1, so minus 1 by 100 plus n2 1.5 upon v equals to n2 minus n1. So that will be 1.5 minus 1 upon 20. Right? So this will be minus 1 by 100 plus 3 by 2v, because 1.5 is also equals to 3 by 2, equals to 0.5 by 20. So it will be 1 by 40. Done? So this will be 3 upon 2v equals to 1 upon 40 plus 1 upon 100. Clear? On solving this, we'll have v equals to 100 centimeter. We can solve this, no problem. See, minus 1 by u plus n2 by v equals to n2 minus n1 by r. This is the formula to calculate. This is the formula to be used for a single spherically refracting surface. So 3 by 2v equals to 1 upon 40, it's 1 by 100. Here the object distance is also negative. Fine, we'll put a negative sign over here. So this will be 3 by 2v equals to 1 upon 40 minus 1 by 100, because object distance is negative. U is negative. I have not put a negative sign over here, so I am placing at this point. So this will be 3 upon 2v equals to LCM 140. 200. 4, 5 minus 100 by 2. So 3 upon 2v equals to 3 upon 200. Right? 3 gets cancelled. So 2v equals to 200. So v is equals to 100 centimeter. So image will be formed at a distance of 100 centimeter. That means B is your correct option. Clear? Fine. The next one. 8th one. And secondary rainbow, refraction and reflection take place. So there are mainly two types of rainbow, primary and secondary. In secondary rainbow, both the refraction and reflection takes place 2 times. That is why secondary rainbow is faint, right? And it is seen at a greater height. So here, refraction and reflection both will take place 2 times. So A is the correct answer. Clear? Fine. The next one. 9th one. Sky is seen bluish because blue light is scattered the most. You know, the scattering of blue light is nearly 8 to 9 times greater than that of red light. Right? So sky will be seen blue because it is scattered the most. So this is again a theoretical MCQ. D is your correct option. Fine. The next one. 10th one. For which of the following image formed is always virtual and erect for any object distance? Image is always formed virtual in case of concave lens and convex mirror. Convex mirror and concave lens will always form a virtual, erect and smaller size image. So presently we are having convex lens, concave lens, plane mirror, concave mirror. So concave lens is the correct option, right? Both concave lens and convex mirror will always form virtual image. Fine. The next one. Okay, 11th one. What should be the refractive index of a prism if angle of minimum deviation is 0? Find delta m is equals to 0. So for a prism, we are having the formula n is equals to sine delta m plus a by 2 upon sine a by 2. Clear? Right? It is given that angle of minimum deviation is 0. Place 0 over here. So n will be sine a by 2 upon sine a by 2. So this will be equals to 1. So refractive index of prism will be 1 when angle of minimum deviation is 0. So C is the correct option. Fine? Clear? The next one. 12th one. Which lens is used to correct astigmatism? In order to correct astigmatism, we will use cylindrical lens. Astigmatism means either the horizontal or the vertical lines are not visible or are seen less visible. For that, we need a cylindrical lens to correct astigmatism. Clear? Fine. So we have completed all the MCQs of ray optics, and in the next video, we will solve the MCQs of wave optics. Thank you.